When we started about 8 years ago, we were really focused on kind of traditional biomaterials and drug delivery experiments, and we saw a unique opportunity to automate some of our experiments. So we began seeing some of the benefits associated with focusing on the kind of autonomous experimentation or automating experiments. And that really resulted in us developing kind of lots of complex data based on our experiments. And when you have a lot of complex data from high throughput automated experiments, a human scientist has a hard time deconstructing that data. And so what we started to embrace was machine learning, which is actually not a tool that we had really any familiarity with before. But it is a very useful tool for deconstructing a lot of these kind of complex experiments. And so once we started to notice that machine learning and automation are really valuable tools for doing really rigorous high throughput experiments and also deconstructing the results of those complex experiments and understanding what is happening, the merging of the two systems together, automation and machine learning, which is a subfield of artificial intelligence, it really starts to almost obviously lend itself towards autonomous experimentation and what we're now referring to as self-driving laboratories.
The concept of the self-driving lab is, I think, a really interesting concept. The idea of being able to, in our case, synthesize a molecule, experiment a bunch of candidates, evaluate the interactions, and do this on a loop continuously. And the implications of it are, far-reaching, kind of outside of our discipline even. It accelerates our own discovery. Its implications can reach, if we think about the next pandemic, screening a different vaccine, carriers and molecules. And in a sense, it can cause us to have, a scientific surge capacity where we're able to test things at the fastest pace we can.
I guess the whole reason I even went to the Gormley Lab was because I noticed this shift in undergraduate research from theoretical understanding to more of a technical approach, knowing more how to do things rather than understanding why we're doing things. And I think that's why I like this whole project behind Dr. Gormley's vision, being able to take the whole synthesis and manufacturing aspect out of research is going to give scientists and researchers so much more time to actually do science. When it comes to actually doing these synthesis reactions, there's some form of error when you have humans do these reactions. Even if you're an expert and have done it several times, sometimes you're tired, sometimes you just forgot to add certain reagents to your solution, and then your entire experiment is not going to work as you thought it would. By using these automated processes, we can decrease this error and ensure that what we're actually making comes out the way we expect every single time.
When you have a PhD student or a postdoc or a researcher at a company, their time is valuable. Their thinking power is what makes them valuable. And what they end up doing is they end up spending most of their time in the laboratory pipetting and doing experiments, right? That's really where they spend most of their time. And the real question is that the best use of their time? Is there an opportunity to instead rely more on their strengths, like thinking and being creative and coming up with ideas, and outsource a lot of that physical work to an automated system that gives them back some of their time, that allows them to spend more time reading and to thinking and being creative. And the other thing is, even scientists who are maybe 100% in the lab really still spend a lot of time in meetings and answering email and doing all the complex things that comes with any kind of normal job. Whereas automation doesn't have any of these exterior habits that they have to work on. And so if you can outsource an experiment to an automated system and it can just do those experiments while the person is sitting back at their desk, that's really valuable.
Another reason why I joined the Gormley Lab, I feel like there's a big shift in biomedical engineering, just bioengineering as a whole, towards automation and using tools such as machine learning or AI to allow for improved optimization of whatever processes we want to do.
I think it's a very interdisciplinary space. And, we have all of the things we need for experiments within an arm's reach. We have 3D printers, we have laser cutters, we have, a lot of stuff that really allows for rapid prototyping and ideation. For example, when we were integrating new diagnostic machinery into our workflow, we noticed one of the grippers didn't fit. And then in the same day, we were able to 3D print custom grippers and overcome that challenge immediately.
Yeah, well, we've been very lucky that we here in biomedical engineering have our own building. right? So this building has been custom built, I think it was 2007, to really meet the requirements of the type of science that we do here. And so we've got cell culture facilities throughout this building. We have an animal facility in the basement. We have fume hoods. We have really most of the facilities that we need to be able to do biomedical engineering here. As we start to grow this idea, this system, I do think that over time, we're going to need to rethink about how we're developing new lab space and actually gearing lab space towards automated systems. And so we actually have some major initiatives and grant proposals that we've written in order to expand the capability and really retool our infrastructure to better enable these types of automated systems in a way that the lab space is originally designed for humans to experiment.